Okay, sorry for
small delay due to technical reason, but now we are going on.
Okay, so apologies for the delay. Thanks. Thank you, Anjay and Keith, for inviting me to this celebration of Konrad's life. And yes, so this is going to be a version of well, it's going to have lots of overlap with the talk I gave in Venice about a year and a half ago. So apologies to those people who were at the same talk, like Keith and Mike and other people. And I see Anjay's put down 3/4 of an hour for this slot, which is long, very long, so I'll be using rather less than 3/4 of an hour. We'll be relieved today. So let's talk about Keith's. This one. Is that right? No, that. Yes. Keith's. Sorry. Talk about Konrad's life and work. I'd just like to thank a few people who kindly helped me write this talk in its original format, given in Venice. Many people here, thank you. And I'll try to overlap with the various talks so far today. It's quite good to be late on, so I don't do so. Again, I'll sort of give a sort of quick run through Konrad's career, but bring in some stories and some things I found out about him and things he used to tell me about. He did his master's degree on relativity, and he told me that at the same time he was doing military service. And he used to sit in a tent, pouring rain, trying to do calculations with exact solutions to the Einstein-Maxwell equations. These calculations are so horribly complicated that seriously made mistakes had to do them repeatedly and try and iron out the errors. Konrad finished his master's and then eventually moved into fluid dynamics via atmospheric physics. This was sort of about his connection with Cambridge because during his time as a student he hitchhiked to the UK. He was working in Brussels with another student, Piotr. I don't know how you pronounce this. How do you pronounce it?
Piotr Remuza.
Okay, Remuza. And they were working in Brussels with wine merchants, earning money and seeing a bit of the rest of Europe. And they hitchhiked to the UK, and they went to visit Cambridge, and they were hitchhiking. They were picked up by a young curate. He wasn't young, he was young at the time, called Gerald Bray, who gave him a lift to Cambridge, and he was surprised. They were from Poland. There weren't many Poles travelling in the UK at that time. He gave him a lift to the youth hostel, found that the hostel was full, and then he found some accommodation for them elsewhere, and they ended up being taken out to dinner and seeing Cambridge and having a very good time visiting the city. And that, as far as I know, is Konrad's first visit to Cambridge, his first connection with Cambridge. Gerald Bray is an interesting character. He has a house in Cambridge or a flat, and he works in the USA. He visited Konrad. After they went back to Brussels, they sort of swapped addresses, and Konrad thought he'd never see Gerald again, but Gerald turned up a few weeks later to visit Brussels and be shown around by these Poles, see the sights. Okay. Also part of Konrad's career was meeting George Bajer. Of course, that's Keith's supervisor, my grandparent in scientific terms, and Konrad's grandparent. Keith was a member of was involved with annual meetings, bringing Eastern Bloc and Western scientists together. And Anjay's father was also heavily involved with this. And Bajer was always very keen to bring bright people to the UK, and met Konrad at some meeting or other, and encouraged him to come to Cambridge. I think Konrad was interested in working on quarks and high energy physics at the time, and Lloyd, I think, suggested that maybe something a bit more fluid dynamic or might be more interesting. And then through that link, Konrad applied to Cambridge and came to Trinity on an external graduate studentship in 1984. Konrad told me that when he turned up at Cambridge, he went to see Bajer, and Bajer had a rather hazy recollection of their meeting, so it had a big impact on Konrad at Bajer when he arrived. Bajer sort of forgot we had this conversation, but Bajer was extremely helpful to Konrad during his time in Cambridge, and Konrad had a great appreciation of George's work and George's assistance during his PhD, and encouraged him to come to Cambridge in the first place. So during that time, Konrad had leave of absence from his post, and spent some time in Cambridge. And here are some photographs. You've seen this one already. Thanks, Sanjay. This is Konrad and Sean from Sean's photograph collection. In fact, it's both from Sean, actually, Jackson, who unfortunately can't be here. I met Konrad briefly in 84, 85, when I was trying to determine where I might do my PhD, and I ended up working with Keith and talked to Konrad about his work at that time. I gather his first year or so was felt quite hard in Cambridge. He spent a lot of time with a copper kettle, drinking coffee and getting used to living in Cambridge and all the demands of doing research there. He was then joined by Gosha. I've got various versions of your name, Margaret. I used to think it was Margaret, but anyway, so joined by Margaret and Ulla and Carol. I think Ulla was born after Konrad was in Cambridge, is that right? Yes, that's right, that's right. And yes, and of course Konrad and I spent a lot of time talking, long coffees, long lunch breaks, lots of time in Trinity College dining room, Trinity College Hall, enjoying lunches and talking about science and everything else. And we also heard about various family crises. I think Ulla had an iron dropped on her hand at some point, hot iron. She had to go to hospital to have skin graft on. So yes, that was quite a difficult time, I think. And I remember Konrad saying he was impressed because when he went to hospital, nobody asked him how he was going to pay for the treatment. The NHS just said, "Oh, the problem, that's sorted out." So Konrad's PhD was published, was completed in '89 with Keith, and Keith will say more about it, but it was about relaxation of magnetic fields, and there's some nice pictures about how these fields relax the viscous medium, and does numerical work. Konrad spent a little while in Nice as well with Annie Pouquet and colleagues, and really enjoyed a month or so there, learning more about numerical methods and enjoying the French lifestyle observed over Nice. The other area which Konrad worked with Keith was in Stokes flow, and I won't go into this, but I've got many memories of Konrad producing these figures. This is the days before laser writers, and these figures were drawn by pen plotters with ink pens. Used to draw things in sort of real time, and apparently these Planck sections used to drive the operators of these machines mad, because the pen would keep going doing dots on a piece of paper for hours on end, sort of making this noise. In fact, one or two of these pictures, when they came back very early on, basically just had holes in the paper because the pen had pierced it so many times. It's not just like just a mess, really. Yeah, so Konrad completed his PhD, went back to Warsaw. I left Cambridge, went to Exeter in due course, and kept in touch a little bit. He then came back for a postdoc position funded by P Park, as it then was, with Keith in these dates, and worked on water scenes, a bit very interesting in vortex dynamics, and some nice papers with Keith on some problems involving vortex dynamics and magnetic fields. I'll focus a little bit on this paper here because this is a paper which has triggered some collaborations with Keith, with Konrad. This paper involves putting down a point vortex in a magnetic field and seeing how the field lines get twisted round by the flow, and you have a process of flux expulsion whereby the field lines are removed from the central region and end up in a thin layer. I'm pleased to say that Christoph and Thomas have already shown some equations. I'll feel free to share some more equations. Just to highlight some of the mathematics involved, is really interesting, and also ties up some really important classical problems. So Konrad took the equation of magnetic field, which I haven't written down in detail, and a vector potential, and plugged in, one button here, plugged in the general axisymmetric flow given by a stream function psi, and you get some equation for the vector potential which gives the field lines, and so the pictures above. And the beauty of this equation is, if you put in a point vortex, so a point vortex in the centre of this domain, you end up with a velocity field here, which is the same as this one, and you get a very nice equation you can solve. So you can plug in you can do various things. You look for a steady state for a start, where this is 0, and you've got an equation which is of a very straightforward type to solve. And the solution involves something times r to the alpha, or alpha, where alpha is a complex number. I always like to teach students fluid dynamics at Exeter, and I like to teach them off at core eddies because it's a nice topic in Stokes flow. And I tell them this is great because you learn about complex powers when you're doing sort of algebra. You think, who would ever care about complex powers? You know, why do we care what 2 to the power 1 plus I is? The beauty is you do it in fluid dynamics because complex powers appear in this kind of problem, and they give you real physical information, as in Keith Moffat's corner eddies. In this case, the complex power gives you oscillations, which corresponds to the boundary layers you get here, with the field lines being wound up by the flow. So it's a paper that Konrad wrote, and it's a single paper back in 1998. I then got, I was in touch with Konrad, and we arranged some collaborative visits funded by British Council and the KBN. And this gave money for him to come to Exeter about once a year for a couple of weeks, for 3 years. And I went to Warsaw a couple of times per week. And we wrote papers with my colleague Andrew Bassam, who's now in Australia. And he's again picked up these ideas of vorticity dynamics. I was also working with Mikhail Branditsky later on. Again, I thought I'd just talk a little about the papers, as it's nice work. So, and it's inspired by Conrad's interest in these sorts of problems. If you take one of these fields and you take a flow, the field lines get turned around and destroyed, as we saw in the previous pictures, and you get the process of flux expulsion. What you realise is that if you look towards the middle, all these processes slow down, and you get flux expulsion sort of outwards. You also get flux expulsion occurring towards the centre of one of the vortices. And this is a limerick by Keith about this problem. I can't say that good Scottish accent you don't have. This is from a word squirrel with virile. You've got some good Scottish accent. Squirrel with virile. Okay, and this links out nicely to some very classical problems. This sort of process, this paper, which I'll say a bit more about in a second. And it goes back to work with Nigel Weiss, who was at Culham at the time, but then went to Cambridge, and he simulates these processes of magnetic field being expelled from closed eddies. This is a very classic paper from 1965, 66, I guess, in which Nigel did some of the first numerics on sort of fluid dynamical problems, really, direct simulations showing this process. But there's a lot about time scales with this. So the paper with Keith worked this problem after Nigel and looked at time scales and came with an R to the third time scale on which this flux expulsion process happens. And there's an acknowledgement in Keith's paper about the about some disagreement about the time scale of the process. I think Keith initially estimated it to be R to the half, and I just said no, it can't be, numeric says it isn't, and then this led to a more detailed investigation given this different time scale. These are very classic papers, of course. This is on a nice long time scale itself, because this is 1981, the other paper was 1966, so there's a 10-year time scale of sorting out some of these problems. Another 10 years or 20 years later or so, this is the same time, sorry, it's 1981. There's similar work at the same time with Rhines and Young, with Burnoff and Lingovich, in the 1990s. Now, we got involved with this. It's the paper with Konrad and Andrew Bassam, and we picked this on the third timescale. As I say, it works for flux expulsion for most of the region, but as you home in towards the middle of these closed streamlines, this starts to go a little bit wrong, actually, because the omega dashed here, the gradient angular velocity disappears, and so the timescale gets longer, but it's not clear how long it gets. And we looked at some idealized problems where you take some flow, which is a Gaussian. This is an angular velocity alpha, taking the flow you get from a Gaussian vorticity distribution. And you look into this process, you have the destruction of field on a RM to the minus third time scale. On to the third time scale, that's what it means there. But then at the core, it gets much longer and turns into RM to the half time scale. I'll show you some pictures of this. This is the sort of picture you get. The explosion occurs, but then as you get towards the very middle of this is the outer region, if you like, here, and the middle. And as you go to the middle, the destruction really occurs in this longer time scale of RM to the half. Okay. Now we also picked this up more recently, and this is fortunately since Konrad passed away, but it's still an ongoing topic, and we looked at some of the dynamical feedback on this. And so we took the problem which involves the spiral winding field, but we also put back in the Lorentz force and allowed the elasticity of the field lines to come in and then modify the process. There's very interesting competition then, very interesting in my view, in that as the field lines are being stretched out and eventually diffused away, they're getting stronger and stronger, and they're essentially trying to resist this process. And so there's a competition. If the field's very weak, the flow wins, and the field lines get pulled out and diffuse, and then you have the flux expulsion process taking place. If the field is strong enough, and as it gets pulled out, it gets stronger and stronger, and then it stops that process and starts to unwind. This is for a very, very weak field, the so-called kinetic region. To make the field very strong, then the field basically winds up and then starts to unwind. So that's the outer region, and in the inner region you've got spiral winder, and it starts to unwind. So if it's a strong field, the process stopped. If you take a moderate field, so in the middle, then the flux expulsion process starts, and the field lines in the middle, which are here, get kind of cut off. We end up with the core, which basically sits there and rotates. And there's a very weak field, that core gets very small. And if it gets weaker again, it gets into a totally kinetic regime. And basically we did some work on this, where you look at the different cases and the thresholds. So you've got a very strong field when the flux expulsion can't occur above here. Below here it does occur and you create some core, and then down here that core becomes very weak and just becomes totally kinematic. And we've got some scaling laws for this, which are those things here, for how strong the field needs to be for flux expulsion to occur, and then for a core to occur which is not kinematic. And this is just a very quick sketch, but the beauty is that this is ongoing work with Joanne Mason and Steve Tobias, and it fits into the general picture that weak fields have a strong effect. And it's a continuing story. There's a paper by Matt Griffiths that uses a slightly different picture, and much of the relationship between these two papers is really quite understood yet, but both are published. So the work that Konrad started with me in Exeter that links to Keith and Nigel Weiss, and is still ongoing, and no doubt will carry on. Konrad's very good at organising conferences, by the way, and we also heard quite a bit about that. I'll just mention a conference which was in Cambridge during our PhD, and Keith and other people asked us to help, and we did various PhD student type of things, organising where people were supposed to be, and all sorts of running around with posters and all sorts of things. It was always very good being with Konrad at these kinds of events, because he's always very communicative and always very open to all sorts of areas of science. At this conference, I remember particularly talking to Bruce Bailey, who was talking about turbulence at the time, but Bruce, of course, was one of the key people in the elliptical instability, and Konrad then built on that work with Keith and Christoph and other people later on. The other person I remember talking to at some length during this conference was Chris Jones, who's now at Leeds, and Chris did a lot of work on superfluids. And in fact, Konrad and I went to a talk by Russell Donnelly from Oregon about experiments involving superfluids, and Konrad's attention being grabbed by this talk. And again, we talked to Chris Jones about it. And again, some of the interesting superfluids, I think, goes back to these early days during the PhD. Conrad's always very open to scientific areas and discussions. There's a whole range of other talks, and conferences that Conrad's involved with. This one with me in Exeter in 2007, and we stayed for the weekend and visited the countryside around where we live. And also the Newton programmes recently, and this one now. Conrad was always, as we heard, a great fan of Cambridge, and his connection goes right back to the early days when he was hitchhiking, and he was very delighted to be a visiting fellow comrade in the Isaac Newton Institute programme in 2012, and I guess it's before he fell off the punt. I hadn't seen the ones in the water, so it's a new one to me. This is Conrad actually, he came to visit us in Exeter, and this is on the beach at Dawlish Warren. Some good walks around there. Andy mentions visiting Trinity late at night during this visit, and it was quite a funny evening actually. The thing was, about 10:30 when we'd finished having dessert, which was all very pleasant, with John Hinch and in Trinity, we left. I thought we were going to just head back home. Conrad produced this key. So it's too late. It's too early to go back home. I've got a master key. Let's see what doors it opens. So, my first surprise was then wandering around Trinity late at night, trying various doors. Not every door, not every door but just hearing what opportunities this key had to offer. And as Andy mentions, this is us in late that night. Behind Trinity. He was kind of staying in Bridge Street at the time, in this amazing building. And I was very glad to spend a few nights with him during this escapade, during this visit. And basically, that's it, I'm afraid. That's the end of my talk. So I will. It's always great knowing Konrad. I learned a lot from him. He was always very open to, as Andy said, open to other people. He was always very keen to understand people and to get on with people. He was also always very good at falling on his feet. So there's so many stories where Konrad fell on his feet in some way or other. And I think it's through being open to talk to people and getting to know people. Okay, thank you very much.